Motion test corrections. A change in position relative to a fixed point is called motion. Every time you change your position, you have to move. Which of the following is an example of velocity? Velocity is speed plus direction. So your answer should have speed and direction in it. Number 3, when a car accelerates, it's changing velocity. Accelerate means to change velocity. So if it's changing velocity, it's changing either its speed or its direction. Which of the following is not accelerating? So we want to know which one's not changing its velocity. So a car slowing down, rather a truck slowing down, yes, you're changing velocity. A stop train, it's doing nothing. A car speeding up or a plane speeding up. This one's doing nothing. The energy of a moving object is called, this is a question that we've had already. So energy of a moving object is called kinetic energy. I need to scroll forward, excuse me for a moment. Okay. Energy of a moving object is kinetic energy. An object will stay at rest because of inertia. This is Newton's first law of motion. An object in rest will stay at rest. An object in motion will stay in motion. Which car is traveling the slowest? Look at this. Which one is traveling the slowest? Well, you could do all the work if you wanted to, and you can find out the speed of each one of them, distance divided by time. So the first one, you would say that it was number 1 at 500 distance. The time it took for 500 is 1.5, et cetera, et cetera. So you can use your calculator and figure that out. Or you can just look at the steepness of the lines. The line that's going to get there the fastest amount of time is going to be the one that has the greatest speed. So the steeper the line, the greater the speed. Car number 4 has the gentlest slope, so therefore it's going to be the slowest. Gentlest slope. This one's the slowest. It never even got to 500 kilometers yet, and car number 1 already did. All right, let's move on to the next page. Question number 8, balance forces. All forces must be equal and opposite. So they have to be in opposite direction, and they should be equal. Average speed of an object can be determined by the formula, distance divided by time. So speed equals distance divided by time. An object will continue to move in a straight line unless acted on by an unbalanced force. Object in motion stays in motion unless acted on by an unbalanced force. This is Newton's first law of motion. Speed of the ball. Speed equals distance divided by time. If the distance is 24 meters and the time is 3 seconds, then your speed is going to be 8 meters per second. If the mass of the rock increases, what happens to the force needed to accelerate the rock? Well, this is Newton's second law of motion. Force equals mass times acceleration. So if you increase the mass, you have to increase the force. We're looking at a stationary cart. Stationary means it's not moving. And it's on a frictionless surface, so there's no friction involved. So we have 2 unequal opposing forces. Opposing forces mean they're opposite forces. Right, we're pulling 360 newtons. Left, we're pulling 270 newtons. So what's going to happen to the cart? If the unequal forces are applied to the cart at the same time, what will occur? They're being applied at the same exact time. So the one that's stronger is going to win. So the cart is going to end up moving to the right. Choice number 2. The cart will move to the right. The force of gravity. This is the one that we get wrong. We got wrong on the last test with the gravity. Gravity changes. So the force of gravity of a person or an object at the surface of a planet is known as gravity changes due to 2 factors, mass and distance. So gravity is the measurement of the pull an object has on one another. So that's weight. That's going to change. Your weight will always change. Your mass is the amount of matter that makes you up. That's not going to change. So in Europe, they measure you in kilograms or they measure your mass because mass doesn't change, but weight does. So you can weigh yourself in 10 different places in your house. You're going to weigh 10 different weights. I mean, maybe by a couple of ounces it'll be wrong, but weight is a measurement of the pull of gravity. Mass is the amount of matter an object has. Okay, 1 through 14. Let's go to the next one. We're going to go 15. This cartoon, yikes, a hill, I can't stop. You're getting the hang of it. This statement summarizes the scientific concept shown in this cartoon. The motion of an object is constantly changing due to magnetic forces? No. The force of friction causes the object in motion to move faster? No. A body in motion will remain in motion unless acted on by an outside force. So this person cannot stop until it held on to the stop sign itself because of Newton's first law of motion. Number 16. Which of the following devices are used to measure and determine the speed of a ball rolling down a ramp? Well, you need a stopwatch and you need distance. You need distance and you need time. So measuring distance would be the ruler and measuring time is the stopwatch. So A and B is your answer. For every action, there's an equal and opposite reaction. So number 17, Newton's third law of motion. Choice number 1 would be the correct answer. Let's go to the next page. Number 18, when a hammer strikes and exerts a force on a nail. This is Newton's third law. There's going to be an equal and opposite force on the hammer. Looking at the next question. It's a roller coaster question. Questions 19 through 21. A, B, and C. A has the most potential energy. B has the most kinetic. C has some potential, but not as much as A. So a car on this roller coaster coasts from point A to point B. It's going down. The speed of the car increases because what happens? Gravity makes it go faster. Is that a balanced force or an unbalanced force? Well, gravity is another force that's pulling it down, so it has to be an unbalanced force. Whenever there's a change in velocity, a change occurs. An object in motion stays in motion unless acted on by an unbalanced force. An object at rest stays at rest unless acted on by an unbalanced force. So you're changing the speed because you have an unbalanced force acting on it. Balanced forces keep everything the same. If they're balanced, they're not going to change. Unbalanced makes it change. So the change is to increase. Number 20, the car is able to travel between points B and C. Why is it able to go up the hill? Because of the inertia from it traveling down the hill. An object in motion stays in motion. What is the force that opposes the motion between the car's wheels and the tracks of the roller coaster? It's going to be opposite of motion. It's going to slow down motion. That's going to be friction. Which of the following is an example of the law of inertia? The law of inertia is the rocket sitting on the ground preparing for takeoff. It needs an outside force to help it move forward. It's not going to go anywhere because the forces are balanced, so it needs an extra push. It needs more force to lift it, so it needs an outside force to move forward. The next question deals with Newton's second law of motion. The best illustration for formula force is equal to mass times acceleration is 3. A rocket that's accelerating through space exerts a great amount of force because its mass and acceleration is so large. So equal and opposite. Looking at questions 24 to 26, we have 2 graphs to look at. There's a graph of a cyclist that is a straight line and a graph of a roller coaster that's straight diagonal. Then it goes straight parallel to the x-axis, and then it kind of like curves a little bit. So 3 different things are happening here, but this is just a straight constant speed in that first one. So what's the average speed of the cyclist? Well, if you take the last answer, which is in between 6 and 7, I mean 6 and 8, so I'm going to say it's probably 7, and then we're going this way, it's probably 70. So 7 divided by 7 is 10 kilometers per hour. What's the average speed of the roller coaster? Well, here we go. 6 is the time. Speed equals distance over time. 6 is the time, and the distance in 6 is about 120. So the speed is going to be 20 meters per second. Some of you got this wrong. Be careful. You were able to use a calculator. And this one, shame on you, you've got that wrong. Units. Be careful. All right. What's happening between seconds 2 and 3 on the roller coaster? It's a line that's straight across, parallel. Time goes, advances and increases, but what happens to the distance? The distance doesn't change. So if time increases but distance doesn't, then the object is not moving. So the only one that says the object is not moving is the fact that the roller coaster is stopped at the top of the hill. In a car accident, a seatbelt prevents injuries by applying a force in the opposite direction because it keeps you there, equal and opposite. It has to be opposite direction of your motion, so it slows you down. For every action, there's an equal and opposite reaction, but for this one, you're going forward, So your inertia wants you to go forward. So you need an unbalanced force to prevent you from going forward. So the unbalanced force would have to be in your opposite direction. So you can stay still. All right, let's go to the next question, 28. A book is sitting on a dashboard of a car that stops at a traffic light. As the car starts to move forward, the book slides off the dashboard. The reasonable explanation is the book is still. The book wants to stay still. The car moves forward. The car wants to go forward. The book slides back because it has inertia. The law of conservation of energy states that energy cannot be created nor destroyed. It just changes form. This is all of these. And finally, question number 30. Question number 30 is showing you a balloon. The balloon is on a string. There's friction between the string and the straw. Now it says, the diagram below shows an inflated balloon attached to a straw that's moving along a string. Air is escaping from the open end of the inflated balloon. Some forces that are acting on the straw are shown by the 4 labeled arrows. So friction, force escaping, the air, the weight of the balloon, etc., force from the string. What causes the balloon to move along the string? It's going to be the force from the escaping air. Every action is an equal and opposite reaction. If the air goes this way, the balloon goes that way. And that actually leads us to the next question. You were supposed to draw arrows. Many of you did not draw arrows correctly because it asked you on the diagram above, draw and label arrows to show the motion of the air. The air is going to go this way, and the balloon's motion is going to go this way. So it asks you to label the motion of the balloon and the motion of the air. The arrows had to be opposite. The balloon and the air go in different directions. Next question. Why is marking the starting position important if the student wants to calculate the average speed? Well, speed equals distance divided by time. If you didn't know where it started, you wouldn't be able to get a proper distance. You need the distance. You need an accurate distance. So you need to figure out where it starts so you know the accurate distance. Many of you said it would mess up your calculations, but you needed to tell me which calculation is two, speed and time, distance and time rather. So you need to include distance. All right, how would taping a coin, so you're adding mass to the balloon, how would that affect the overall motion? Force equals mass times acceleration. This would actually make it slow down because if you're adding a mass, it's going to take more force. You have the same amount of air in there, so the motion affecting the overall motion. A lot of you did not answer this question. How would it affect the overall motion? Well, motion is how it moves. So the balloon would move slower because it had less force. It would have the same amount of force, so it accelerates slower because you're adding more mass. If the string were extremely long, what would eventually happen to the motion of the balloon? Explain why. There was a couple of answers that I accepted for this. The balloon would slow down. The balloon would stop. The balloon would stop because of friction. It would run out of air. These are answers that I accepted. The balloon would stop because of friction. That's the answer that you should have said. Or it would stop because it ran out of air. But because of friction is what they really wanted. Because an object in motion stays in motion except when it's acted on by an outside force or an unbalanced force. The unbalanced force is the friction. So some of you wrote that it would go on forever. No, only if it was frictionless. And they didn't say it was frictionless. And you need to explain why. That's some people didn't do that. And they didn't explain the motion. If they ask you a question about motion, you have to talk about motion. All right. Student is rolling a ball down a ramp to see how far it will travel in 10 seconds. How far? The student would like to change the experiment to get different results. List 2 variables the student could change and explain the effect it would have on distance the ball travels. We ask you to underline keywords for a reason. What do they want to know? The effect it will have on distance. I would say 90% of you told me. How would it affect the speed? Does it want to know about speed? No, just the distance. So the variable we're going to change, well, they're only showing you 2 things. So if we're changing the ramp, you have to tell me what you're doing to the ramp. So you want to increase the height of the ramp. If I increase the height of the ramp, what's going to happen to the distance? Well, the ball will roll farther. You want to talk about distance. if I increase the mass. If I increase the mass of the ball will roll farther. If I decrease the mass of the ball will roll not as far. You want to talk about distance. So you can shorten the height of the ramp and the ball will not roll as far. You can lessen the mass and the ball will not roll as far. So you need to make sure that you answer the questions properly. Okay, that concludes your test corrections.